switch this room around well enough. All right, so today, oh shit. Let's see if this works. Come on, you can do it, little dude. There we go. Today we're going to get into everybody's favorite thing. You've been wondering when this is going to happen. So today we're going to finally do some word problems. So, one of the worst things, and I will say this, one of the worst things about word problems for students, and I think I put this on our syllabus or our homework sheet. Did I put the one about Sally saying only in math can you buy 60 cantaloupes and nobody asks what the hell's wrong with it? So you often get these dumb frickin' word problems. Like, Sam forgot how much money he put into his tube bag. I'm like, who the shit is Sam? What? How much money does he have? Like, was it 28,000 or 57,000? Right? What do you mean you forgot? So he's got to work backwards to figure out how much money. You're like, that doesn't make any sense. Or, Sam goes to the store and buys 87 watermelons. And you're like, what kind of party is this? Why am I not invited? Right? So it's like, these problems don't make the most sense. But the more math you learn, the more real life the problems can become. So for example, do you remember the hurricane that sort of became a tropical storm and blew through San Diego? Mm-hmm. You guys remember that? Okay. I used to live in Florida, and we would pay a lot of attention to the cone of uncertainty of the hurricane as it would come, right? And it could be anywhere within there or outside of whatever. How many variables go into that? Figuring out where a hurricane's going to go. A stupid amount, and that's why it so sucks. But it used to be much worse, right? So the more math we learn, the more variables we can use in an equation at one time, the more real it can become. So when we're first learning some stuff, it's not going to be the most real. It almost can't be. With all that said, let me see. Do I want to do that? Where did I put that? Here it is. Sure, why not? Everybody pick a number. Let's do this together. Everybody pick a number and just write it down. You ready? Just pick a number. I'm going to pick a number. You guys pick a number. Any number you want. So if you want to be really mean to yourself, you could use square root of 72 if you want to, or square root of whatever. Don't. I'm going to use 11. Whatever number you want. You with me? Okay, triple that number. Ooh. All right, some of you guys, I don't know if you do it in your head. If you don't want to play, just scribble something. Now add 9 to your number. All right, now divide your number by 3. And of course, right now you can use the calculator if you want to. Now subtract the original number. Okay, what did you guys get? I got 3, but I started with number 11, right? What else? What did you guys get? Did anybody else get 3? Anybody not get 3? Good, because if you didn't get 3, you did it wrong. Did anybody else start with an 11? No. What did you start with? Just give me an example. What did you start with? 10, 2, 7, 11. But we all ended with 3. You've all heard this stupid thing before, right? And sometimes it's like, add the number of TVs in your house, subtract the year you were born, and all this kind of bullshit, yes?
Yeah, I did make 3.
Trust me, you made a mistake. So what number did you start with?
6.
6. And then you triple it, right?
Yeah.
And then what was the next thing? Add 9. Divide by 3. Subtract the original number. Yeah.
Oh, okay.
Yeah. You're okay. Now, real quick, so based on what we just did, do you think that the answer is always 3? What do you think? Did anybody not get 3? Look around. How many people are in this room? A lot. Is it proof that the answer will always be 3? You could do this. No. Is it really good evidence? Yes. How do you prove this damn thing? You use a variable. if I wanted to start with every number I could, did anyone start with a negative number? What if I start with a negative number and the answer comes out to not be 3? Could that possibly happen? Of course, right? You guys with me a little bit? I really want you with. So how do I prove this shit? Well, let's start with every number. X. Right? Now triple that. And then add 9. So we're going to do all the same stuff. Right? Now divide it by 3. What do you get when you divide it by 3? X plus 3. Now subtract the original number. Right? Okay. All right. So the power of variables is the fact that they can stand for every possible thing. You guys sound kind of with. They can stand for every possible number. Okay, so we all know this, and you've all seen this kind of thing before. I don't know if you've ever seen the proof of it, though. You just start with every number. So if I told you, I've got 2 numbers. Right? In fact, let's make this real life. Let's say Frank makes twice as much as Joe. Twice as much money, right, at his job. You with me? And then I say that 1 week together. Oh shit, Jeff, really? They made, let me think. Yeah, sure, why not? Yeah, sure. They made $3,000. How much do each of them make? So if I just tell you Frank makes twice as much as Joe, do you know how much either one of them makes? If I just say that, if I tell you Frank makes twice as much as Joe, you don't have a freaking clue. Is it possible they both make no money? Yes. If Joe makes 0, then Frank makes twice 0, which is 0, right? I don't know. Are you guys with me? Give me one possible situation. So couldn't Joe make $1,500 a week? And that would mean Frank would make how much? 3,000. But those add up to be 4,500, right? So if Joe made 1,500, Frank would make 3,000. That can't be the actual answer to the whole problem because it doesn't make 3,000, makes 4,500. Do you guys follow? How many answers are there to just this statement? Infinite. Okay, I like it. So what the shit do we do then? Well, we start with every number and then we work backwards. That's what algebra does. I don't know how much money either one of these crazy people makes. Who should I know first, though? Who's a little bit easier if I know that? Joe. I like you playing along, but why? Joe's a little bit easier because I just have to double him. I don't have to cut him in half, right? So do we know how much money Joe makes? We have no idea. So we're going to pretend like we do. He makes X dollars. He just does. So now we can write how much Frank makes. So all word problems do is they say, okay, we don't know this shit. But if I did know it, I know what I would do with it. Are you guys kind of with me?
Yes.
If I did know, I would just double. Yeah, so if Joe makes X, how much does Frank make? 2X. Come on, Pen.
Why not X squared?
Because it doesn't say that Frank makes the square of Joe. Frank makes double Joe.
Okay.
Twice as much, 2 times. So that's what this is, right? And there's an infinite number of possibilities for this. Whatever X is, Frank is twice that. Okay, you all look very appropriately excited. That's it. All right. How do I represent this?
Well, probably equal. Wait, no.
Together, so mathematically that would just be to do what with these? Together, X plus 2X, together they made 3,000.
Oh, and you just do
Now, is anyone at all interested in, like, anybody ever watch any crime shows or anybody majoring in AOJ even? Or no? Okay. The rest of you guys, do you care about detective stuff at all? You're like, if I say no, do I not have to do this? No, you still have to do this. So this is sort of like if you're trying to solve a murder, do you have a lot of variables that you don't know?
Yes.
Yes. So what do you start to do? You start to collect data. You start to collect as much as you can about the variables that you don't know. So this is one piece of information. This is another piece of information. Together we can figure out who killed. Well, thankfully nobody died here. Right? So how do you solve this? This is beautiful. Once you get to the solving an equation stage, you should go, thank God. What the shit does this mean? If you just circle that, is that good enough?
That's how much Joe.
That's how much Joe makes. Joe makes $1,000. So how much does Frank make every week? $2,000. All right. So that's all a word problem is the stuff we don't know, but we know what they do together. If I just gave them math names, I can then do shit to them, right? If I just have empty space plus empty space, I can't, what's that mean? So I have to give them names and then show relationships. Whatever this is twice this. Did I have to use the letter X here? No, you could have used the letter M. You could have used the letter J for Joe. You could have used a freaking little happy face, and this would be twice happy face, right? The symbol doesn't matter. It just represents the thing I don't know. Okay, so let me give you this. Now, of course, you wish all word problems would just be like this, but they don't. They're not. Crap. Five. Big with numbers. I don't want to spend too much time on this. The neat thing is, if you go on our Canvas shell, I actually have answers to this up in there. But let's take a look. So I have a couple of examples put out for you. So there are several steps to an actual word problem. I like to call it the players. So looking back here, the players in the problem were Frank and Joe. In fact, Frank and Joe's salary, right? Well, we kind of know we're talking about salary. You guys with me? So identify the players, write them down in English. And then our first thing is to translate from English into Mathish. So that was from here to here. So this is what Joe looks like in mathematically, his salary, and this is what Frank's salary looks like mathematically. Okay, I like it. So we got the players. So in this case, certain triangle has a perimeter of 23 feet, largest side, middle side, shortest side. Okay, so we got three sides. The players are the three side lengths. So I put shortest side, largest side, middle side. You guys all with? Why did I make shortest side X? Well, because the other two depend on each other. Do you see how the largest side is 3 times the shortest, the middle side is blah, blah, blah. So I have to know the shortest one first, correct? The most important immediate first step in a word problem, the most important one is what the hell is just X? Because then everything else builds on that. Okay, I like it. So if that's X, then the largest side is just going to be 3X, 3 times as large. And then the middle side, now be careful about this, 1 less than twice the shortest. I always get somebody write 1 minus 2X. You guys with me? English sucks. I don't know if you guys know this. If you grew up in English, you don't understand. I did too, so I don't understand really either, but if you had to learn English after you learned a different language, you know English sucks. What is 1 less than 10? 9. So if you write 1 minus 10, is that correct?
No.
Hell no. So 1 less than twice the shortest is twice the shortest minus 1. You have to turn it around, yes.
But wouldn't that be if X is like 1, then wouldn't 1 less than twice the shortest just be X?
If X were 1, then twice 1 minus 1 would be 1.
Because, yeah, and then the shortest side and the middle side would be the same.
Beautiful. So is the answer probably going to be 1? In fact, go even further. What if X was 1/3? Wouldn't this be 2/3 minus 1, which is negative? Are there answers for X that don't make physical sense?
Yes.
Totally. are those going to probably be the answers we get? If we do get those answers, what does that mean?
Did it wrong.
And we did all the work right. So either you did work wrong, or it's just an impossible problem.
You put no solution.
You put no solution. Yeah. But most often, if you get like a negative side length of a shed, you made a mistake. And the most likely mistake you made is you didn't write 2x minus 1, you wrote 1 minus 2x. Do you see how the x becomes the opposite sign then? And shit gets weird? Okay. Stop for a minute. Okay. The players translate from English to Mathish. Use the exact same words I use in the word problem, so that you can go back and forth easy, right? Be nice to yourself. So there's a translate from English to Mathish. Well, that's actually a translate. And then I have to write the perimeter is 23. That's what sets up my equation. Perimeter of any object means to do what? Add up all the sides. So if I have all the sides, and I do, I just add them all up, and I know that they make 23. All right. And then you solve it, and then you make sure that you totally answer the question. You answer all three parts, blah, blah, blah. You guys all with me? A little bit? And then I gave you one more example. This is more like the Frank one. So you had a concert. There were 363 total people, but there's twice as many women than men. Well, actually, 3 more than twice. So why is men X? Why did I make men X? Good, because the other one depends on it. I have to know the men first, so then I can double it and add 3 to it. So figuring out which thing is just X is really important, and it should be relatively easy. Everybody else just needs to know it to work themselves out, right? And then you go through the same steps. Okay, I'm going a little fast, but, it's all review. All right, let's try 2 of these problems out, and then we're going to go to the next idea. Oh, shit. Let's try number 3, since I have an example just like that. Try number 3 real quick. Oh, yeah. That's right. I still need a big. That's right. Let me catch up to you guys a little bit. What are the players?
Long side is X.
Don't tell me anything else, just the players. What are the players? Longest side? Middle? Shortest. I love it. All right, just make sure everybody's on the right track. The people that skip this step are the people that are going to make mistakes. All right, now which one of those is just X? Yeah, and that's pretty obvious, right? The shortest side depends on the longest. The third depends on the longest. So I got to know what the longest is first. Now, what would the middle side now be? Actually, is there a middle side? There's a shortest side, a longest side, and a third side. There we go. So that's all kind of nice that happened. Use the exact same language the problem does. So when you go back to look at it, you know where the hell things came from. So the longest side is X. What's the shortest side?
X minus.
Yeah, 15 less than that, so X minus 15. And what's the third side?
X minus 6.
X minus 6.
But how come it's worded different?
What do you mean? Sorry.
So it says 15 feet less there, but then that says
Just to make sure you understand that there's multiple ways to say the same thing. I could have said 6 feet less,
Yes.
and I could have said 15 feet shorter, right? So that's another thing about English. There's about 78 million ways to say something. Yeah. In math, it all translates to this kind of thing, right? Okay, how we all doing? And then to get the perimeter, of course, I have to do what? Add everything. So I got to add this side to this side to this side. Make sure you can find all the pieces. And together they make 102. Okay, yes, ma'am.
So do you use parentheses when you add like the?
You can, but they're unnecessary because they would all have a 1 in front of them. So you could just immediately distribute the 1 and take them down. But I kind of underline them, but there's nothing wrong with doing this so you know you can see all 3. But either way you do it, what do you get next?
Because I just thought like the positive would redistribute to like 6 and 15, but
Yeah, it would, but they don't change. It's not like doubling them. It's just positive x is positive x, right? So nothing changes. When I get 3x here, right? 3x minus 21. Add 21. Real quick. I like to throw this at you guys. I'm going to tell you a few, does anyone know how to tell very quickly if any number I give you is divisible by 3? Besides, just do this, Jeff. No. Just looking at it, how do you know if it's divisible by 3?
Add each of the numbers.
Yeah. So 1 plus 2 plus 3 is 6. And why does it tell me it's divisible by 3?
If it's 3, 6, or 9,
If it comes up to any multiple of 3, it's divisible by 3. Do you guys know that?
I just looked at the last number. Is that okay?
13. Is 13 divisible by 3? Oh, shit. Because 1 plus 3 is 4. 15. Is 15 divisible by 3? 1 plus 5 is 6. So the rule for 3 is if you add all the digits and the number you get is divisible by 3, the whole number is divisible by 3. Did anyone know that? You did.
I didn't know that, but that's very helpful.
It's super helpful. I'll tell you one more. There's rules for almost every number. How do I tell if something's divisible by 4? Like here, this number is divisible by 4. You ready? Look at this shit. This number is divisible by 4. Here we go. Okay, that number is divisible by 4. Why? What are the last 2 digits?
Oh,
40. Does 4 go into 40? Therefore, the 4 goes in the whole thing.
So you look at the last two.
Yes. Does 4 go into 100? So therefore, does 4 go to 108? Of course, because it goes into 100 and it goes into 8, correct? So does 4 go into 216? Yes, because it goes into 200s and it goes into 16. That's why you only have to look at the last 2 digits. Do you guys understand what I'm saying at all? Okay. And again, if you've never heard this before, you should be a little upset. Don't you wish you knew this a long time ago? Now everybody knows 5. 5's easy. How do you tell something's divisible by 5? It's got to end in a 5 or a 0. Cool. All right, enough of that. I'm sorry. So you divide by 3 and you get,
40.
and if you circle that and go on, you're going to lose a lot of points.
Oh, you have to put it in English.
Well, yeah, you have so what's the longest side? 41
Side is 40 feet.
feet. Good. Please don't, listen, I am a dork. Don't force me to be even more dorky. If you just put 41, I'm going to say cows, something stupid like that, right? I'm going to say something stupid like sheep, shoelaces, So make sure you put the freaking unit down. What about the third side would be, 41 minus 6. Who is it? What? 35 feet. And then the shortest side will be 41 minus 15, 26 feet. All right. And then how do you check that? What are they all supposed to know? Even better. What are they all supposed to do? Add to 102. So you just add them up. Do they make 102?
I'm assuming.
Don't ever make an assumption, because then you make an ass out of you and umption. Yes, okay. All right.
So you don't have to put it in a sentence?
No, this is beautiful. You told me, so setting it up helps you answer the question. I don't need a sentence. Okay.
So even with the ones where it's like asking with people and stuff, you don't need to say, oh, Martha has blank more than.
Well, you will, right here. This says the longest is 41 feet. So if you just said the longest side is 41 feet, you didn't give me any more information than this already does, right? Okay. All right, now, scheisse. I'm going to do one thing. Okay, I'm going to do several things. Again, go on Canvas. The answers to most of these are up on Canvas, believe it or not. This is in Chapter 2. They're still in Chapter 2. I want to talk really quickly about, well, I'm going to put it up there. Sure, Jeff. All right. Damn it. I'm going to talk real quick about complex numbers. Does anyone know what I mean when I say complex number? Yes, okay. This is so cool. Okay. This is so desperately cool. Let me see if you guys agree with me. Everybody make a number line. Put 0 and 1. Okay, right? Just go with me. When you multiply by -1, so multiply 1 by -1, what do you get? It's amazing. What do you get? It's not a trick question. Yeah, you get -1. So multiplying, now look, visually, multiplying by a negative number just means turn halfway. Do you guys see that? What's -2 times -1? -2 times -1. Yes, don't you turn halfway? Do you guys follow? Okay, maybe. Stay with me now. Stay with me. So what if let me draw it again. I need some more room. What if I multiply by half of -1? You could do this. You could do it. So what do I mean by that? So up here it was -1 times 1, right? And that would got us a half term. So what if I multiply -1 to the 1/2 times 1? Instead of, in fact, can somebody tell me how many degrees this is? Do you guys know how many degrees that is? 180 degrees, correct? So multiplying by a full -1 is a 180 degree turn. Do you have to suddenly look at negative numbers like that? No, this is just another way to look at them. It's a beautifully visual way to look at them. When I multiply by negative, I just do a half turn. That's what happens, correct? I just go to the other side of the number line, don't I? So if I multiply by half a -1, I'm going to make a what degree turn? 90 degree turn. So I'm going to go here. What the shit is this? All right, well, officially the answer to this would be the square root of -1, correct? There is a problem with the square root of -1. It is not what we call a real number. And it was just a bad name that we applied. So they should have been called, and I agree, I'm going to show you a quick video here in a second because I have time. They should have been called lateral numbers because they lie on the side of the number line. So this would be the square root of -1, and just to make it easier to work with, we give it the letter I.
So why isn't it 0?
Why is it what 0?
Because it goes to 0. That might be a stupid.
It turns, yeah. So I'm at a rate, I'm like 1 out, correct? So if I turn half of a turn, I'm going to end up here. So if I do 1 times -1, then I'm going to turn a full turn. I'm going to do this. This is 1 times -1. I'm going to just turn like that. If I do 1 times half a -1, I'm going to go halfway. So I'm going to stop here. And we just have to give that a symbol. We just decided to call it I.
But that's
No.
not 0 though. It's over.
Like the Y.
True, but that's not 0 though, of course. I mean, what point is this?
Oh, because you're looking at it. Okay. I see.
Isn't this the point? Is that the point 0? No.
No.
That's the y equals 1, correct?
Yeah.
So here, This is real.
Is that what you're drawing?
This is unfortunately called imaginary.
Okay, I see what you're saying.
Okay, I like it. And I'm sorry, I didn't know what you meant at first. That doesn't go to 0, it goes to that thing which we call I. Now, I love you guys. I love you guys. Let me show you this video. Now, real quick, before I do that, what if I did another half turn? Where would I end up?
-1.
And let's see if that makes sense. What's the square root of -1 times the square root of -1? Isn't that the square root of -1 squared? Is that cool? Anything times itself is that thing squared, correct? What do the square and the square root do? Cancel, so you're left with what? Which is exactly where we should be, correct? If I go by half a -1 and then half a -1, I just multiply by a full -1. There I am at -1. I'm right where I'm supposed to be. I love you guys. Even before I said any of this shit, if I just said to you, what's square root of 7 times square root of 7? What is that? And if I said square root of -1 times square root of -1, ignore the fact that right now we say that that's not real, what would that be? -1, correct? That's what that would be, by definition. So this is the first time we're seeing something that when you multiply by itself, you get a negative answer. This is the first time we've ever seen it. So let me show you this video, and then I'll let you out of here. Let me let the ad play real quick. I'm gonna stop this or I'm gonna get copyright strike.